So now that we've kind of conquered the first rule for simplifying radicals down, square roots down, we can now look at those other rules for simplest form. So in order to tackle those, though, we're going to need another rule. So the next rule is going to be the quotient rule. We had the product rule, which allows us to combine two square roots into one when we multiply them. This one is very much the same idea. If we're dividing two square roots, we can combine them into one, and vice versa. So if we have a fraction under a square root, we can split it into two square roots. So that's how we're going to get around that second rule. So that's what we got to do here for this first problem. We have a single fraction underneath the square root. We'll split it in two. Square root of 7 over the square root of 4. Now, we're not done because now we're breaking rule number 3. Remember, rule number 3 said if the denominator has a square root, we don't want it. But what do we know about the square root of 4? Yeah, it's a perfect square. It's a perfect square. So we can get rid of that square root of 4 and change it into a 2. Now all things are in alignment and we don't have to worry about any issues. So this is your answer, square root of 7 over 2. Now, what happens when the bottom is not a perfect square? Well, let's take a look at this one. Square root of 9 over the square root of 7. So there would be step 1. Now, if you have perfect squares that you can simplify, I would say let's do it. So in this case, the square root of 9, remember, is a perfect square. So let's change that into a 3. So we got 3 over the square root of 7. Okay, so now the square root of 7, though, is not anything we can really simplify down. So what do we do? How do we get rid of it? Well, the trick is to multiply this by 1. Now, wait a minute, you're saying multiply by 1? So how does multiplying it by 1 do anything? Well, remember, we can write 1 a lot of different ways. So we're not going to write it as a 1. We're going to write it as a fraction. And specifically, because this square root of 7 is the problem, we're going to write it as the square root of 7 over the square root of 7. Because this will simplify down to 1. So we're not changing the value of our original fraction at all. But what happens now is that we can multiply using the product rule. So the top, we really can't combine the 3 and the 7 at all. So that's just going to become 3 square root of 7. But on the bottom, the product rule says if you're multiplying two square roots together, you can smush them together into 1. So this becomes the square root of 49. Well, that doesn't look any better. Well, it is better because what do we know about 49? 49 is a perfect square. So we can get rid of this 49 and change it to a 7. So your final answer is going to be 3 square root of 7 all over 7. Now, do you need to write this step here? If you kind of got the idea of why this happens the way it does, those two square roots of 7 can just say, oh, I got basically a half of a square root of half of a 7 and another half of a 7. I'm going to make a whole 7 out of it. That's fine. You know, as long as you understand why that happens the way it does, then you can jump right to your answer. But technically, this is what's happening behind the scenes. Okay, let's do one more of those, and then we're going to take a look at the last set of problems. So we got the square root of 8 over the square root of 3 on this one. So that's step 1, break them apart. Now, the square root of 8, we can simplify that down. We've already done it a couple of times. Let's just cut to the chase. We should know at this point that that's equal to 2 square root of 2. Remember, 4 and 2 divide it, split that apart. Square root of 4 is a perfect square. So we got 2 square root of 2 over the square root of 3. So how are we going to fix this one? The big thing to keep in mind is that the square root of 2 is not hurting anybody. It's in the top. We only care about square roots if they're in the bottom of the fraction. So that square root of 3 is the problem. So just like we did over here, the square root of 7 was the problem. So we multiplied top and bottom by the square root of 7. Same idea. we're going to multiply the top and bottom by the square root of 3 to fix this one. So what do we get in the top? So we got the 2, the square root of 2, and the square root of 3. Can we combine any of that? Hopefully you're saying yes. 2 and the square root of 2 and the square root of 3, we can combine those together because we're multiplying. So that's going to become the square root of 6. So the 2 in front comes along. We got the square root of 6. And then if we do a little cheat here, we got a square root of 3 and a square root of 3. So that's just going to become a 3. And that's it. There's your answer. So these ones can be a little tricky, but the big thing is the bottom. The bottom square root is where we got to fix it. And so that's what you're going to multiply the top and bottom by. All right. Now let's jump to the last set of applications, which gets into adding and subtracting square roots. So this section, this part is a little funky, but the rule says it all. Combining square roots by adding and subtracting can be done only if they have the same radical, the same square root. In this sense, we can use the distributive property to combine the radicals. So, looking at this first problem, we got 3 square root of 6 plus 4 square root of 6. So the square roots are the same. So that's key. Now, if we want to use the distributive property to do this, the distributive property we can use in both directions. So remember, the distributive property looks like this. That's the distributive property. We basically have something that looks like this, and we want to make it look like this. So what we're going to do is take the 3 and the 4 out and package those together as a sum. The square root of 6, we're going to pull that out and put it on the outside of that. So this is going to look like 3 plus 4 square root of 6, which is just 7 square root of 6. Now, sometimes the distributive property can be a little bit confusing, but here's the way I would think of it. Think of that square root of 6 as like a piece of fruit, like an apple. So if I got 3 apples and I got 4 of the same type of apple, how many apples do I got? I got 7 apples. That's it. So you don't have to do anything with the apples part of it. You don't have to square it or double it or anything. All you care about is that's the name of your fruit. So I got 7 square root of 6 in this case. All right. What happens when the fruits aren't the same? Well, in this case, we're going to have to do a little front end work to get them the same. So the square root of 3 we can't do anything with, but the square root of 27 we can. So we got the square root of 3 plus, and if we break this apart, which we did previously, we got 9 and 3. So this becomes the square root of 3, and then 3 square root of 3. So what's this going to become? Our square roots are the same, so that's key. But there's an imaginary 1 that we got to put in front of that square root of 3. So we do have 1 apple and 3 of the same type of apple. So altogether we got 4 apples. So 4 square root of 3. Those ones could be tricky. But remember, you can always put a number in front, a 1 in front, and it doesn't change the value of it. So let's try the last couple. Now both of these are fairly large, so we really should break them both down. So 45. So what's a perfect square that goes into 45? Well, hopefully you're saying 9. 9 and 5. Now we did square root of 80 on the previous page, but if we didn't, what's a cheat that we can use? Well, if you know that you've got one of these broken down as far as you can, so this one would be 3 square root of 5. Square root of 5 is as small as it gets. Hopefully, and 99.99% of the time, you're going to see it happen, this one has to have a square root of 5 in there. There's no way around it. You aren't going to be able to combine them if they don't have the same square root. So if you got one of them down correctly, the other one is going to have that same piece. So we know there's a square root of 5 over here. But from before, we already know that the square root of 16 was the other piece, and we still got that 3 in front. So be careful. So the square root of 16 we know is 4. And we still got the square root of 5. So it looks like we got 12 square root of 5 for the second piece. So 3 square root of 5 minus 12 square root of 5. 3 minus 12. Well, remember, if the bigger one's second, it's just going to be negative. So this should be a negative 9 square root of 5. 12 minus 3 is 9, so 3 minus 12 is negative 9. So, all right, last one. But wait a minute. The two square roots are the same. What's the problem? If I put a 1 in front of this, isn't this just going to be equal to 3 square root of 8? Done? Well, what's wrong with it? Yeah, the square root of 8 is not in simplest form, so technically you're not done. So you do have to do a little bit of work, but we can break down the square root of 8 pretty darn fast. So 6 square root of 2 should be the answer. Now, if you're not comfortable with that, what's another way you could tackle it? Well, we could simplify both of those square roots of 8 down right at the beginning of the problem and then see what happens. So let's do that just real quick, just to confirm. So we got 2, and then the square root of 8, which is 4 and 2, plus, and we got another 4 and 2 for the other square root of 8. So this becomes 2 times 2 square root of 2, and 2 square root of 2. So this is 4 square root of 2, and 2 square root of 2, which, lo and behold, gives you the same answer. So 6 square root of 2 again. All right, so that wraps up this section. A lot of layers to it. It's got some similarities to fractions, but it's definitely got its uniquenesses. So, all right, that wraps it up, and let's see you in the next videos.